We'd like to thank the Cloud Native Computing Foundation for sponsoring our podcast from CloudNativeCon in Seattle. Inspired by internet-scale computing, the Cloud Native Computing Foundation advances the development of cloud-native technology and services by creating a new set of common container technologies informed by technical merit and end-user value. You can learn more about the Cloud Native Computing Foundation at cncf.io. Hey, it's Alex Williams, the New Stack here in the afternoon at the first day of KubeCon Cloud Native Day here in Seattle. It's a busy event. We're very lucky to have with us Dimitri from Aporeto. Dimitri, thank you for joining us. I'm also here with Lee Calcote, who has worked with the New Stack quite a bit and now is with SolarWinds. And so Lee has a background in networking, so I thought we would spend some time having a good conversation. Dimitri, tell us a little bit about yourself, and then we'll get into a little bit of Aporeto.
Well, thanks for inviting us, first of all, Alex. And it's a pleasure to be here today. KubeCon is really moving, and the community is very exciting. Just a little bit of a background. We have started this company called Aporeto about a year ago. We are focusing on trying to solve lots of security problems around container deployments, Kubernetes deployments, Mesos deployments. Myself, I'm coming from the network world. I used to be the CTO and co-founder of Nuaz Networks. That was an SDN network virtualization company. And I transitioned when I realized that there is a lot of security issues that people are trying to solve on the network, and probably the network is not the right way to do that.
The network is not the right way to do that. What do you mean by that?
Well, I think we have been trained for the last, 20, 30 years to think that anytime we deal with security, we try to do it by dealing with IP packets or looking on packets or trying to guess what packets are doing or what applications are trying to do in the packets. And in reality, the opportunity we have with the cloud is that now we understand what applications are doing. We have much more context. And by moving security where it really belongs, that is close to the applications, we can simplify the network, right? So in the end of the day, we need to decouple security from the network.
So what do you think of that, Lee?
Sort of decouple security from the network and maybe attach it more to the application?
Correct.
Oh, okay.
Exactly.
Yeah, I love it. Just the application, the crowning of the application as king continues.
Exactly, right? So because if you think about it, right, when you're sitting on the network, it's like, sometimes I call it like playing the Marco Polo game. You are sitting there watching the packets go around.
Marco.
Exactly, right? And you are trying to guess what the applications are doing. 90% of the security things we do in the network is trying to guess what applications are doing. And if you think now about a Kubernetes environment, about a container environment, we have tons of metadata at the edges. We know exactly what people are delivering. We know what images they are using. We know what vulnerabilities are in the images. We have so much context that if we use it, we can make security actually very simple.
Yep, it sounds like one of the premises that you guys are pointing out here is the notion that maybe the days of identifying a network entity by IP address and maybe port are maybe beginning to be in our rearview mirror.
Right, and again, if you also think about it, right, when we the rate at which we activate microservices and the number of microservices, right, is essentially increasing by an order of magnitude. And it becomes pretty much impossible to keep track of these things, right? We have to think of these ephemeral microservices as things that come and go, and we need to deal with security for them, but we cannot attach them to a location. We cannot attach them to a static thing like an IP address. It doesn't make sense.
What about the things that are not ephemeral?
Well, even for the things that are not ephemeral, right, they are just the simplest form of the ephemeral things in a way, right? I mean, we can treat them in the same unified way. In both cases, we have increasingly more context. And I think you said earlier application is king. I actually think when it comes to security, context is king. The more context you have, the more security you can apply, right? All the way, right? It's I think actually this is the trick on security. Context is king.
Yeah, a royal family. Okay, so it could be a new crowning happening. Okay,
Right.
context. So you guys, and by the way, Alex may have this enunciation down, and I probably don't. But your open source project,
Right.
Pronounce that for me if you
Right.
would.
So I was told on a website that the right way to pronounce it is Trireme, but
Okay.
I won't hold it against you.
Okay, fair enough. And then,
You don't pronounce it the right way.
Okay.
for our listeners, though, a little bit about what that is.
Right, so Trireme is actually a very simple open source library that allows somebody to deploy end-to-end application segmentation. Essentially, it allows people to drive policy that define that two applications can talk to each other only if policy allows it to happen. Now, instead of using networking techniques, instead of using ACLs, instead of using VLANs, VXLANs, whatever, it actually uses end-to-end authentication and authorization. It's a little purist on its approach, meaning it's the pure form of security says end-to-end authentication, authorization, encryption everywhere. That's what it's trying to do. So it's introducing end-to-end authentication and authorization for applications without requiring application developers to go change their code. And that is a fundamental requirement here, because if we ask them to change their code, they will never do it. So we have open source Trireme and we have open sourced an integration with Kubernetes. The beauty of Kubernetes is that it has already a security policy, a network policy API, and that allows us to essentially provide security policy within a Kubernetes environment in a very simple way, very efficient way. So you just deploy this library and you're pretty much done. You don't need any complexity other than that in your infrastructure. So that's the benefit of Trireme, and that's why we're so excited with Kubernetes that we can do that.
Makes sense, and it's specifically Kubernetes 1.4. Is that right? So we're talking
I think
fresh.
it first came. It's an experimental API that came out of the networking SIG on 1.3 and 1.4, and it's been maturing on every release.
But I love that approach, and actually, Alex has been speaking with folks about distributed tracing and kind of open tracing being a new project, and part of the challenge, as I understand it in that space, is the notion that in order to benefit from a distributed tracing system, depending upon what system the application is going for, the developer might have to instrument and kind of change some code to benefit from that. And the beautiful thing...
Right, so in our case, at least for the security functions, we don't need to instrument the code, right? And security has this other thing also, that security tends to be better if there is a separation of concerns, meaning if I bundle security inside the application code, then it's good because I have a lot of context. At the same time, there is the problem that the first thing that the bad guy will do is, if he manages to attack an application, it will disable security, right? It's the classic chicken and egg problem. So ideally, you want security to be at an arm's length, if you want, from what it's trying to protect, right? It's this chicken and egg situation that we need to solve in this space.
So how do you solve that with the segmentation technology itself?
So with the segmentation technology, what we are achieving is we're essentially minimizing the attack surface of applications. We're essentially minimizing, actually the right terminology is the blast radius. If an application gets affected, infected, whatever, gets pwned, then it can only potentially affect other applications in the very close proximity. It cannot touch other data, other applications far away on the system, right? That's the one reason that people have embraced segmentation. And the other reason, to be honest, in a lot of operational environments is they have a QA environment and a production environment, and the last thing they want is some runaway QA process to be talking to the production process or using production data, right? I mean, there are some practical problems like that people are trying to solve in their installations that are not even security, they are more, let's avoid the silliness kind of thing.
Yeah, just sort of mishaps that people have.
Mishap, right? I mean, accidents. I mean, there is a famous story in Wall Street, actually, that somebody misconfigured something and there was a QA application that attacked the NASDAQ and brought down like the whole NASDAQ, right? I mean, people are trying to avoid even simple things like that.
Right. There's a term for that, isn't there? Where like the automation goes wrong, essentially.
Something like that.
We'll just say that.
We may have to make one up right now if we can't.
So you run now on Kubernetes.
Right.
Do you run across any distro? Do you have the ability to run across any infrastructure and any distro?
So right now we just open sourced our project. It runs with Kubernetes and Docker. Soon it will also be running with Mesos Marathon, right? And we are in the process of doing a lot of trials with customers and so on to try to prove the concept, mature the code. Again, we chose the path of open source for some very, I think, philosophical, if you want, reasons. I believe strongly that security has to be done in open source, so people can check what you are doing. It's a very good idea to have a lot of eyes on the code, right? Yeah. And I also think that we are changing a little bit the conversation, and it's important for people to be able to build more stuff on top of this, right? So that's why we chose this open source approach.
As I understand it too, you use the Docker Event API?
Right, so we actually have a very extensible, it's an extensible library. It can use the Docker Event API, it can use the Kubernetes API, it can use the Rocket Event API. So it's actually not
right. It's not container specific.
It's not really specific to Docker only, right? We build the library with interfaces in Go that somebody can swap modules and use the same technology in other neighborhood areas if you want.
So now you can take that data from those APIs,
right,
and then you can then collect that metadata. And what do you do with that?
So we collect the metadata, right? So for example, when a container gets activated, we collect the metadata that describe the container, and based on this metadata, we create an identity. And the identity now is signed by a cryptographic key, and that becomes what will identify this container to the rest of the world. So now, anytime this container tries to talk to another container, or this process tries to talk to another process, we piggyback the identity on the TCP negotiation stream. So essentially, the identity arrives now on the other side. The other side validates the signature, makes sure it's right, validates the attributes of the identity against the policy, and allows or denies the connection. But this means that we don't really care now what the network is in the middle. We don't care if you do network address translation or whatever. Everything is about the identity of the payloads, of the containers, of the processes end to end, right? Everything is about, and I think increasingly we are going to see that in this environment, that workloads will get identities, and management of policies will be done based on the identities of the workloads.
And then, Dimitri, I think you just hit kind of the crux of it, right? The secret, the sort of the main value add, or sort of secret sauce of Trireme, if I
right.
didn't Trireme, totally slaughtered it, brings today, which is going back to
Trireme if you want.
Trireme. I'm not that sophisticated, unfortunately. Is the notion that code doesn't need to be changed, that part of that identification mechanism is done in context of labels and annotations that are set specific to those containers, specific to those applications, that part of that secret sauce, if you will, is not so secret since it's open, but is the SYN and the ACK, or the SYN and the SYN ACK that happens. This isn't, as I understand it, not necessarily the first time that folks have tried to exchange context.
Right. I mean, it's funny enough that, and I'm a little bit of a history buff, I like to go back and figure out what happened in the past, right? When we thought about it, I'm like, cannot be the first guys thinking about that, right? So, the first implementation of something like that we actually saw back in the early 90s. It was done by the US government, where they were piggybacking essentially context or identity as IP options on packets. And then they would have their routers, the government routers would look at this identity, and they would separate in this way their secret network from their confidential network from their public network. So it was actually mandatory for a while. If you're going to sell a router to the government, you have to have something like that. Now, doing things on IP packets, on IP options, right, ends up being a problem because high-speed routers tend to drop them, and also they are not cryptographically signed and all these things, right? So we have these other approaches now, but it's interesting to see that the three-letter agencies were very much in love with this type of approach a long time ago.
So back to that, so you mentioned two hiccups there with using IP options. One, not necessarily supported by all of your data center infrastructure. Moreover, maybe your cloud provider's infrastructure.
Correct.
Secondarily, just not necessarily cryptographically verified.
Right. And there are use cases that people told us that the attack surface they are trying to protect is that they are running in a foreign data center on some country far away. It's a big company, has data center wherever, and they don't necessarily trust the operator. They don't trust that somebody is not going to plug a wire on the router and try to get access to their application and data, and that's why they like the idea of end-to-end security, right? And security, it's a little crazy to say it or whatever we're going to say it, but the ultimate goal of security, right, is always end-to-end. I'm a very big fond of end-to-end principle when it comes to security and systems, right? That's the...
So, speaking of end-to-end, and kind of back to some of the questions Alex was asking about the approach of the technology that you have, sounds like, it's sort of foremost the focus on integrating with Kubernetes as an orchestration system, not that you're limited to deploying within a Kubernetes-only environment, that you've got, a little bit of a nascent Docker story there, as well as just deploying an agent or daemon on a Linux node itself. But I guess to further Alex's question, what about Windows environments?
So the technology is perfectly portable to Windows, right? We are a small company right now. We are limited resources, but that's why we open sourced it. If anybody wants to look at it and try to extend our open source code in Windows,
there you go.
Okay. We would love that.
Go for it.
Go for it.
So I have a question about the risks of using different APIs from different providers. So be it Docker or Rocket, they can limit their APIs at any time, and that could create some kind of some shortcomings.
Right. So first of all, I don't think any of them has any reason to do that, right, in the first place, because they won't. This is perfectly complementary with whatever they are doing, and I think the community is increasingly mandating, open APIs. Now, as you said correctly, though, there are a lot of them. This, fortunately or unfortunately, whatever we want to call it, this space is still very fluid. We don't know who the winners and the losers and who is going to dominate the equation.
They all open in different ways, don't they?
Right, they are open in different ways, but so far we don't think, we have a very easy... We have enough endpoint information. Actually, one could even implement it with even basic Linux system services and things like that, right? So there is plenty of ways to grab metadata, right? I think it's the easiest thing. I think at the same time, Kubernetes has shown some leadership in terms of expressing security policy concepts all the way up to the API that people can consume them. So they have a step ahead there. But I think the others will catch up, right? I think we'll see similar security policies in Docker. We'll see potentially security policy definition in Mesos, Marathon, whatever the other fracture is.
So when I was talking earlier with Ben Sigelman of Lightreach, and he's behind Open Tracing, and he says one of their dreams is to go beyond the API and to go right to the wire, right?
Right.
Is that a reality for something like for your technology, or is it really not?
Now,
does it really matter?
It doesn't really matter at this point, right? I don't think we have any concern like that. One thing that we very specifically try to do in the way we build this thing is to stay away from the Linux kernel. Essentially, no drivers, no kernel modules, no modifications on the kernel. Because anytime you do that, you have a whole bunch of operational problems until it's accepted upstream, until it's streamlined, picked up by the distributions and all this kind of things.
And we have seen that approach. There's companies that are building interfaces to the kernel itself.
Right. So we are really trying to avoid any kernel. We don't want to, the kernel is the kernel, it's golden. I like to treat it like an ASIC. I'm gonna use it as it is, and don't muck around with the kernel, because if we could we could implement the same thing potentially more efficiently, right, with kernel modules. But it will be like, well, it's an uphill battle now to improve adoption, right?
You just highlighted the kind of part of the choice between whether or not to use kernel or to not, and to use it is for efficiency and performance. So speaking of which, since you're using user space and you do have that SYN and SYNAC, that initial kind of three-way handshake to verify identity, a little bit of user space.
So this is the trick there, right? Exactly, right? So we only capture these first packets in user space. We don't care about the rest. And exactly for a very specific reason, because we want, for example, the NICs to take care of TCP offloads and to deal with all these things. So the performance actually that you see is, for a high-speed TCP bundle throughput, is native TCP performance. Nobody will even notice, right? That's the trick. I think it's very important to let the NICs and do their job down there and not interfere with these things.
And so the beautiful thing about this type of approach is whether it's underlay or overlay or whatever driver that people want to use, this is sort of in front of that, before that comes into play, and you're out of the way before those even.
Right. It doesn't really matter what networking technology you choose to use.
Now, Docker takes a different approach, don't they, to the security of the node itself? They put the cryptography on the node itself, as I understand.
So Docker has a lot of security capabilities in terms of securing the kernel from the containers, right? They do a lot of system call security and so on. In Docker Swarm, when they set up Docker Swarm clusters, they also introduce TLS end-to-end for security by itself. When it comes to the corresponding area where we are working, they try to do security by using the libnetwork interface and VXLAN and networking, right? And I think it works fine in small installations. Coming from the background I'm coming and having lived through large SDN deployments, I can tell you that let's put it this way. Let's leave it there.
Yeah, we'll leave it there.
We'll leave it there.
There's the cost for convenience in some cases. Boy, a couple of future, facing questions maybe are, young company, have made a big open source announcement, recently around. Trireme?
Trireme.
Oh, boy. Okay. But just, kind of business model going forward for you guys as a young...
So, this is very early stages for us. We have a much larger vision, if you want. The vision, if you want, the big vision here is that we cannot just use the mechanisms of yesterday, the security mechanisms of yesterday, to implement security in cloud-native applications. We have to pretty much revisit everything. Security is across a lot of layers. It's not just the network. Network is just the one leg of the stool, let's say. There are another 5 or 6 legs of the stool. What you will see from us is that we will increasingly start offering more and more of these things that allows us to essentially secure cloud-native applications in a cloud-native manner, essentially thinking away from the infrastructure, abstracting the infrastructure. We have to abstract security the same way we're abstracting the infrastructure, essentially.
I think that leads into the second part of my question is, it's cloud native security, and it's kind of, which is fantastic and certainly future facing, but is seemingly constrained to that. Is that kind of the problem space you guys are going to stay with?
We are focusing on this problem space for the time being. We know that, for example, even the Trireme stuff can be applied backwards to a lot of existing environments. If somebody deploys their applications with Ceph and Puppet, we can do the exact same type of thing with Trireme, right? So we are a small company for the time being. We are focusing. We have to be hyper-focused, and we will see where the world takes us.
Now, the segmentation technology is built on Go, correct?
Correct.
Right. Okay.
Correct. So it's a Go library. Feel free to go to GitHub, Aporeto Inc./Trireme, and things are there. And send us feedback. Right? What we are asking for people is, get us feedback to try to improve this.
Well, Dimitri, I totally love your enthusiasm for your technology and and just your passion for it. So thank you very much for taking some time to talk with us. It's very interesting and kind of points to a new kind of thinking about networking and security itself. And we're starting to see this in a lot of different places. And so it's fun to see this movement grow and you guys be a part of it.
Well, absolutely. And thanks a lot for inviting us over. And thanks, Lee, for the conversation.
It's good to have you, Dimitri.
Thank you.
We'd like to thank the Cloud Native Computing Foundation for sponsoring our podcast from CloudNativeCon in Seattle. Inspired by internet-scale computing, the Cloud Native Computing Foundation advances the development of cloud-native technology and services by creating a new set of common container technologies informed by technical merit and end-user value. You can learn more about the Cloud Native Computing Foundation at cncf.io.